and then go to our notes. All right, so this is 8.4, and it's going to be about theorems about zeros. And just remember, zeros are just our solutions we get. All right, so this first example, they want us to find a polynomial function of degree 3 with real coefficients that has the given zeros. So the given zeros are given me are -1, 2, and -5. So let's see what they want. It's a polynomial, so we know that's going to be like degree 3. So they want me to have an x to the third can be my highest variable with an exponent. I can't have an x to the 4 or x to the 5. They're saying that I got to end up with an x to the third as my polynomial's highest exponent. And they're giving me these real zeros. So what we're going to do, we're going to work this problem in reverse. So the first thing you would do, since these are zeros, that means that all three of these are solutions. So we know that x would equal -1, x equals +2, and x equals -5. Right? Zeros in solutions we learned were the same things. Now, we're going to work backwards. All right, because if we started with a polynomial to get these type of zeros, we're now going to start with the zeros and go back to that polynomial. So the first thing we would do to all of these is where we got these numbers, we want the right side to be a 0. So we need to get a 0 on the right side of all of these. So get 0 on the right sides. So to get a 0 here, I would add 1 to both sides, and I would get x plus 1 equals 0. Second one, since that's a +2, we would subtract 2 from both sides, and I get x minus 2 equals 0. And then the third one, since that's a -5, I would add 5 to both sides, and I get x plus 5 equals 0. But we learned that the other day, that all these factors always had opposite signs than our solutions, okay? So now, I would take all three of these and put them together in parentheses and set all of that equal to 0. So right before we would have factored it, got 3 parentheses equal to 0. Then we set them each to 0 to go back to get these answers. So remember, we're going totally the opposite way. So set all factors as a product and equal to 0. Okay, so that's what we're doing there. We're setting them as a product. Now the third thing is we're going to start foiling. So y'all, what I'm going to do, the easiest way to do these, you could start with the first 2 to foil, but what I'm actually going to do is foil the last 2 first. That way I'll have the 2 up here, and then this, when I get done foiling, it'll eventually give me 3 terms. So then I'll have my 2 in front and then my 3 in the back. So what I'm going to do is bring down the x plus 1. right here, I'm going to make big parentheses because I'm about to FOIL this part right here. So we're going to FOIL that. So we got an x times an x would be an x squared. X times 5 would be a 5x. Negative 2 times x is a negative 2x. And then negative 2 times 5 is a negative 10. So now, before I try to multiply by this x plus 1, I got like terms. I'm going to add the like terms. So bring down the x plus 1. I'm still going to have big parentheses, all equal to 0. So the x squared would come down. 5 minus 2 would give me a positive 3x, and then minus my 10. So now there's nothing else I can do inside the second parentheses. So what I'm going to do now to finish this problem is FOIL all of this. Now it's just like FOILing. You're going to take this x and we'll multiply by all 3 of these terms. And then I'll take the 1 and multiply by all 3 of these terms. So both of these times all of these. So y'all watch this. X times x squared is an x to the third. X times 3x is a 3x squared. So on the x's, just add those exponents. X times negative 10 is a negative 10x. Now I go to the 1 and start distributing the 1. 1 times x squared is an x squared. 1 times 3x is a positive 3x. 1 times negative 10 is a negative 10, all equal to my 0. And y'all, the last thing to do is combine like terms. But if you notice, the biggest exponent I have in here is that 3. And that's what they told me to find was a polynomial of degree 3. So after I add my like terms, we're going to be done. So the x3, there's no other x3s, so I bring it down. Right here I got 3x squareds. They're going to add to a positive 1x squared and make a positive 4x squared. X's will add together. I got negative 10x's. I'm going to add the 3x's. Negative 10 plus 3 gives me negative 7x's. And then y'all at the end is my negative 10. And technically all this is equal to 0. But all they were looking for was the x to the third plus the 4x squared minus the 7x minus 10. And on some of these, they'll give you most of the answer, and you might just have to put in that number or the negative 7 or the negative 10, okay? Just remember, when I'm looking for a polynomial degree 3, my final answer, that's got to be the largest exponent. So let me let y'all write that, because next, we're going to go with imaginary numbers. Might have been a while since y'all played with imaginary numbers. So y'all want to flip my paper now if y'all are ready. And basically the first 5 problems or so, we're going to be doing this kind of work, okay? So this one just says find a polynomial in standard form with real coefficients. That just means We want real numbers. We don't want no imaginary numbers on our final polynomial, okay? With zeros of 5, 4i, and negative 4i. Now remember, to get these I-type zeros, they probably was using the quadratic formula like we was using the other day, because you're not able to factor them and get the imaginary stuff, but you can do square roots and the quadratic formula to get the imaginary stuff. But y'all, this is going to be the same way. I got 3 zeros, which means I got 3 answers. I got x equals 5, x will equal 4i, and x will equal a negative 4i. So 2 of these are imaginary zeros. Okay? Now, let me tell you this. When you got 3 zeros, you're going to have the highest degree be a 3, because remember the other day, we were saying that the degree did equal the maximum number of zeros, okay? Now, we want to do like we did a while ago and get a 0 on the right side of all these. So I'm going to subtract 5 from the first equation. X minus 5 equals 0. Subtract 4i from the second equation. X minus 4i will equal 0. And then add 4i to the third one. And I get x plus 4i equals 0. Okay, so basically I'm moving them to the other side, changing their signs, and setting them equal to 0. Now we're going to take all 3 of these factors, put them in parentheses, and set that equal to 0. All right, so I've got everything set equal to 0 as a product. So now I'm going to start FOILing this. Now, you could start with those first 2, but you're going to get an ugly answer. Anytime you got imaginary factors like this, a negative 4i and a positive 4i, these are conjugate pairs, and you always want to start with those conjugate pairs on these imaginaries. So that's going to be the first thing I'm going to FOIL, because if you FOIL conjugate pairs, it cancels out all the imaginary stuff when we're done, okay? So watch how this is going to happen. This x minus 5 I'm going to bring down. This I'm going to make in a big parenthesis because I'm going to FOIL this. I got an x times an x, that's an x squared. I got x times 4i, that's just going to be a positive 4ix. So I usually just put all my imaginary stuff and then my variable. In the middle, negative 4i times x is a negative 4ix. Now, y'all, here's the tricky part. Negative 4i times a positive 4i is a negative 16i squared. Now, watch this. There's a little I on the calculator above the decimal down here. So all you got to do to get the I is hit second decimal, and it'll bring up the I. So watch this. This was a negative 4i, so negative 4 second decimal to get my I, times a positive 4i, so second decimal to get the I. That gave me 16. I got negative 16i squared, y'all. But watch this. If you take this I and square it, the I squared part of this equals a negative 1. So watch this. I'm going to bring down the x minus 5. What happens to these like terms in the middle? I got a positive 4i. I got a negative 4ix. Those are going to cancel. Okay? So what we'll bring down is the x squared. Negative 16i squared. Remember, I squared equals negative 1. So that's really negative 16 times negative 1, which will make that a positive 16. And all this is equal to 0. So y'all, anytime we FOIL conjugate pairs of imaginary numbers, it always ends up being positive, okay? Always positive. Now, I got two things here, two things here. I'm now going to FOIL that together. So let's FOIL this. X times x squared is x to the third. X times 16 is 16x. Negative 5 times x squared is a negative 5x squared. And then negative 5 times 16 is a negative 80, all equal to 0. Now, the only thing I would probably do to that is rearrange it and get it in order so that I get my x to the third minus my 5x squared plus my 16x minus my 80. All that's technically equal to 0, which y'all remember all Math Lab wants is that polynomial. And notice I had 3 zeros and my highest exponent was a 3. So y'all just remember, anytime you get an I squared, you got to replace that with a negative 1, okay? And these, when you FOIL imaginaries, will always cancel the imaginary part so that all you end up with is real numbers, okay? All right, y'all, so if you had fun with imaginary, the next one's going to use radicals. So here we go. Find a polynomial of lowest degree with real coefficients and zeros of, oh, let me find my zeros, where'd they go? Square root of 7, negative square root of 7, and 4. Now, y'all, I'm going to be picky since I got radicals. Those are really almost like the imaginary numbers. So what I'm going to do when I put my stuff, I'm going to put the 4 first. I'm going to put x equals 4, x equals a square root of 7, and x equals a negative square root of 7. So once again, to get these type of zeros, they would have had to solve it by square roots or the quadratic formula, okay? So get zeros on the right side by subtracting and adding. So I'm going to subtract 4 from the first one because that 4 is positive. So x minus 4 equals 0. I'll subtract square root of 7 from the second one. And then on the third one, we'll add the square root of 7. So if you notice, I was talking about a lot of foiling today, and y'all, that's all we've done is foiled, right? All right, so let me put something there to hold my paper down. How about that? All right, so put them all in parentheses, equal to 0. And now is the fun part. We get to start foiling. These are conjugate pairs. Conjugate pairs always look the same other than one's being subtracted and one's being added, okay? And then when you're dealing with radicals, just like the imaginary numbers, that's the first thing you want to FOIL. Because when I FOIL conjugate pairs of radicals, it'll get rid of those radicals. So bring down your x minus 4. And then let's make big parentheses for this. Now remember, on a radical, outside stuff can only multiply by outside. Inside the radical can only multiply by stuff inside the radical. So watch what we're doing. This x times this x is an x squared. This x times that square root of 7, the x is outside, the 7 is inside, so they can't multiply together. So you just got to leave that as a square root of 7 and then your x. But the x is not under that radical, okay? All right, then you would do the negative square root of 7 times x is a negative square root of 7 times x. Once again, that x is not under the radical. And then y'all watch this. Negative square root of 7 times a positive square root of 7 is a negative square root. Now, this 7's under the radical, that 7's under the radical, so they can multiply together and make that a 49. So watch what's going to happen. The x minus 4 is going to come down. Then I'll have these parentheses all equal to 0. But notice in the middle, a positive square root of 7, negative square root of 7, those cancel. Conjugate pairs always cancel the two center terms. So we got an x squared minus, so now what is the square root of 49? Square root of 49 is 7. So notice, all the radicals are gone, and I'm going to end up with real numbers again. Now, check this out. A square root of 7 times a square root of 7 in the long run equals 7. So that goes back to this principle. Anything times itself in a radical equals itself. Okay? Or you could do like I did. Square root of a times square root of a equals square root of a squared. But the square root of a squared is still an a. Okay? Because like 49 was the 7 squared. All right, so radicals are gone. So now we will FOIL this. And remember, I had 3 zeros, so I should end up with a x to the third somewhere, okay? Oh, and y'all watch this. X times x squared is x to the third. X times negative 7 is a negative 7x. Negative 4 times x squared is a negative 4x squared. And then finally, my negative 4 times negative 7 is a positive 28. So the only thing I would do maybe is rearrange. So my x to the third would be first. Then my negative 4x squared. Then my negative 7x, my positive 28, all equal to 0. And then y'all, the math lab would only want the actual polynomial. So these first 3 problems, I had 3 zeros and ended up with a degree 3 on those, okay? See, oh, we're going to do one with a fraction next. So let me let y'all catch up on that page. All righty. Find a polynomial degree 3. with the given zeros. And those are going to be negative 1/3, 0, and 5. So I know when I'm done, I'm going to end up with an x to the third on these. Now, y'all, I'll tell you something. Zeros are my favorite zeros because those are the easiest to do. That 1/3 might be a little tricky, but not too bad. So anytime I got a 0, I make that one my first answer, because that's going to be the one I want to multiply last. Then I'm going to put my x equals a negative 1/3, and then x equals 5. Okay? So things I do on these, I put my radical ones and my imaginary ones together like I did a while ago. And if I got a 0, I put it first. Because, y'all, you can't do nothing to that. That one's solved. But this one, to solve this one, since that's a fraction, my first thing I would do to this is multiply both sides by 3. Because guess what? This gives you 3x. And this side, the 3's cancel and leave you a negative 1. Now, the last thing I got to do to get a 0 there is add 1 to both sides. So 3x plus 1 equals 0. So, y'all, anytime you got a fraction, put that number in front of the x and then add or subtract your number to the other side. This one has a positive 5. We're going to subtract 5 from both sides. So I get x minus 5 equals 0. So I've got my 3 answers. So this one, all you got is an x. Then I'm going to put parentheses, 3x plus 1, parentheses, x minus 5. All this equal to 0. Now, you could have put this one in parentheses, but you really didn't need it because it only had one term. Anything that had 2 terms, I definitely put them in parentheses. Now, I'm going to FOIL these 2 first. So this x will come down, and then I'll have my parentheses all equal to 0. All right, y'all, here we go. 3x times x is a 3x squared. 3x times negative 5 is a negative 15x. 1 times x is a 1x. And then 1 times 5 is a negative 5. Now, before I mess with this x, I do have like terms I'm going to add in the middle. So bring that x down. So the 3x squared will come down. Negative 15x's plus 1x's leaves me negative 14x, and then minus my 5. So nothing else I can do here. Now the reason I left this x for last is I'm just going to distribute it through now and be done. X times 3x squared is a 3x to the third. X times negative 14x is a negative 14x squared. And then x times negative 5 is a negative 5x. All of that equal to 0. And y'all, once again, MathLab only wants that polynomial. So y'all, they're not too bad. It's just really, like I said, a lot of foiling, and I got at least one more to doing some foiling. And this next one will sort of see what you remember from yesterday. All right, y'all, so moving on. So now they're going to get a little tricky. They want me to find a polynomial degree 4 with -4, a 0 of multiplicity 3 and 0 as a 0 of multiplicity 1. So it's a degree 4, so I know it has 4 zeros. And watch this. They said -4 is a 0 of multiplicity 3. Remember, that means that one happens 3 times. So you would have x equals -4, x equals -4, x equals -4. So that's what it means by multiplicity 3, is that 1 0 happened 3 times. And then it says 0 is a 0 of multiplicity 1, so that means that 0 happened 1 time. Okay? Now, when I put these in parentheses, I'm putting this one first because it's just a single x again. So on all these, since they're -4, we would add 4. So x plus 4 equals 0. X plus 4 equals 0. X plus 4 equals 0. So y'all watch what I'm going to do. I'm going to put this x first, and then I'll do the x plus 4, x plus 4, x plus 4, all equal to 0. So you know this is going to be a lot of foiling, right? If the bigger these degrees get, the more foiling we do. All right, so watch this. We're going to FOIL the last two first. So I'm going to bring down this x. I'm going to bring down this x plus 4, and I'm going to FOIL all of that into my big parentheses. All right, y'all, let's see what we get. X times x is x squared. X times 4 is 4x. 4 times x is 4x. And then 4 times 4 is 16. And before we do any more multiplying, we're going to add like terms. So bring down that x. Bring down that x plus 4. And let's add like terms in our parentheses. So the x squared comes down. 4x's plus 4x's gives us 8x plus my 16. Now there's nothing else you can add in here. So you would now FOIL this. Now remember, you don't have to FOIL the exact same order I do. You can start with these x's and just have bigger exponents as you're going through, but it'll still work. So this x I'm going to bring down. Then I'm going to have big parentheses because I've got two things times 3. So this x is going to multiply by everybody. X times x squared is x to the 3rd. X times 8x is 8x squared. X times 16 is 16x. Now we do the 4. 4 times x squared is a 4x squared. 4 times 8x is a 32x. Ooh, and then 4 times 16 is 64. So y'all, this one is x to the 3rd plus 8x squared plus 16x plus 4x squared plus 32x plus 64. 64 is a little hard to see there. So let me add like terms. So bring this x down. Nothing else adds to the x to the 3rd. The 8x squared will add to the 4x squared and give me 12x squared. The 16x here will add to the 32x. 16 and 32 give me 48x. And then the only number I have is my 64 at the end. All right, y'all, we'll say this. The bad part's over. Now all we got to do is take this one little x and distribute it through the parentheses. So x times x to the third is x to the fourth. X times 12x squared is a 12x to the third. X times 48x is a 48x squared. And then x times 64 is 64x. All equal to 0. And once again, MathLab wants that polynomial. Okay, y'all, so you just got to look at what they're asking for, like degree 3, degree 4. And remember, this multiplicity, when they use those words, tells you how many times you had that 0, okay? All right, so what I'll do is I'm going to flip this over. Now, there's a few things we know about zeros. Okay? So, these are just a few properties about zeros. Well, the first one says that radical zeros always come in conjugate pairs. So what that means from radical, if square root of 7 is a 0, then negative square root of 7 is also a 0. If 5 plus square root of 2 is a 0, then 5 minus square root of 2 is also a 0. Okay, so they can be single radicals. If one's positive, you got to have a negative one also. Or they could be what we call conjugate pairs, where you got a real number and a radical. So 5 plus square root of 2, if that's a 0, then 5 minus square root of 2 is a 0. Notice the 5 don't change signs. Only the radical parts change the signs. All right, so guess what? Imaginary zeros always come in conjugate pairs. You know, that makes sense because imaginary zeros are really radicals, okay? So what we mean is if 5i is a 0, then negative 5i is also a 0. And they can look like a real number and imaginary. You can have something like if negative 3 plus 7i is a 0, then negative 3 minus 7i is also a 0. Once again, the negative 3 stays the same. The only thing that's changing signs is the 7i to a negative 7i, okay? So where this is leading to is this next question. Suppose a polynomial degree 4 has zeros of -3, square root of 3, 11/2. Find the other zero. So they want me to find the other zero, and that's not going to take no work because I know what we just wrote above. Now, I can't know nothing about that -3 or that 11/2, but I do know that that square root of 3 is a radical, and it tells me up here that radical zeros always come in conjugate pairs. So the other zero would be a negative square root of 3. And that since radicals come in conjugate pairs. Okay, so that's all we had to do to that one, and we get to move on. So I'll do another one like that real quick of using this, okay? All right, so this one says polynomial degree 4 has the zeros of 5 plus 4i and 4 plus square root of 2. Find the other zeros. All right, so let's see what I know about these. This is imaginary, and we said a while ago, imaginary zeros come in conjugate pairs. So remember, you do not change the sign of the 5. You only change the sign of the imaginary part. So that would be a 5 minus 4i. This is a radical, same thing as this. We don't change the sign of the 4. We only change the sign of the radical part. And this would be since imaginary and radical zeros always come in conjugate pairs. All right, so watch this. Find the polynomial lowest degree. With zeros of square root of 3 and 4i. And remember, it's got to have rational coefficients, real coefficients, all that stuff. Now, I know if square root of 3 is 0, so if square root of 3 is a 0, then negative square root of 3 is a 0. I also know if 4i is a 0, then negative 4i is a 0. So I know I got 4 answers. I'm going to have x equals square root of 3, x equals negative square root of 3, x equals 4i, and x equals negative 4i. So notice, this is the part where they want me to find those polynomials again. So y'all, where all these are, we need zeros. So subtract and add to get everything to the other side. So x minus square root of 3 equals 0. This will be added. X plus square root of 3 equals 0. Minus the 4i on this one. And then the last one, add 4i. All right, and I like this order because I like these two being grouped together in front and these two being grouped together in the back. So here we go. Put them all in parentheses. All equal to 0. Now what's nice on this one is I can FOIL these two together and these two together. Since these are conjugates, I want them two to go first. These ones are also conjugates. I want these two to also go first. So I'm going to have two big sets of parentheses after I FOIL this. These two go here. These two will go here. So here we go. X times x is an x squared. X times square root of 3 is a square root of 3x. Negative square root of 3 times x is a negative square root of 3x. And then negative square root of 3 times a positive square root of 3 is a negative square root of 9. But remember, instead of putting square root of 9 there, since that radical is times itself, you could have just put a 3 without a radical, okay? Now, in a second, I will take care of those like terms because those are going to cancel. All right, let me get this one out of the way. X times x is x squared. X times 4i is a 4ix. Negative 4i times x is a negative 4ix. Then here's that tricky part. Negative 4i times 4i is a negative 16i squared. So I'm going to cancel these like terms in the middle. I'm going to cancel these like terms in the middle. So let's see what's going to happen. That x squared will come down. Minus, well, the square root of 9 is 3. So take the square root of 9 and come out as a 3. Or like I said, you could have said, oh, square root of 3 times square root of 3 is just a 3. So remember, when you FOIL conjugate pairs of radicals, you always get minus that number. And when we FOIL conjugate pairs of imaginary, it's always going to be positive. So watch this. The x squared comes down. 4i, negative 4i cancel. And remember, negative 16i squared, negative 16, second decimal squared, is going to give me a positive 16. Y'all remember, it's always going to do that. Imaginary is positive, radicals are negative. All right, last step, FOIL this. So x squared times x squared is x to the 4. X squared times 16 is 16x squared. Negative 3 times x squared is a negative 3x squared. And then negative 3 times 16 is a negative 48, all equal to 0. And y'all, I'm going to bring that over to the side because the last thing I got to do is add those like terms in the middle. So bring over your x4. 16 minus 3 give you 13x squared minus 48, all equal to 0. And then once again, all MATLAB wants is my polynomial. So remember, they want you to find a polynomial lowest degree and they give you radicals or imaginary, you got to write those conjugates down, okay? Because those are also solutions. Woo, y'all, I'm about talked out, so I'm going to have to take a break and put us on pause this time. Get it back up and go to my screen. All right, so this next problem is going to pull in some of what we learned yesterday. So let me write it down and show you what we got to do. So for the following polynomial one zero is given. It says find the remaining zeros. So the polynomial is going to be p of x equals x to the fourth plus 72x squared minus 729. And they're telling me 9i is a zero. So we're going to start using some synthetic division, because if I use synthetic division, I can divide these zeros out and then take those quotients I get and divide more zeros out. Now I do know one thing. Since 9i is a zero, we know for sure negative 9i is a zero. But to remember, we got an x4 here, so that means I'm going to have 4 zeros, and that's only 2 of them. So we got to use synthetic division to find all of these last 2, okay? So remember, synthetic division, I write my coefficients out. So I got a 1 for the x4 term. There's not an x3 term here, so I got to put a 0 for the x to the third term. My x squared term is a 72. I don't have an x term up here, so in place of the x term, I would put a 0. And then my constant number is a 729 negative. Okay, so remember, when it's a degree 4, you add 1 to that, you got to have 5 numbers here. So I'm going to draw my little box thing. So the first number I'm going to check is the one they gave me. They said 9i is a 0, so I'm going to start with 9i. Now remember, since 9i is a 0, when you get done with this, you better have a 0 remainder, because that's what it means to be a 0, okay? So watch this. The first number always goes straight down. Then we multiply. 1 times 9i is 9i. 0 plus 9i is 9i. Now watch this. 9i times 9i. So watch this, y'all. 9 second decimal times 9 second decimal to get the I. So that's a 9i times 9i. Watch this. It's going to be a negative 81. All right. Negative 81 plus 72. We're going to add them, and that's going to give me what? A negative 9. So watch this. Negative 9 times 9i is a negative 81i. 0 plus a negative 81i is a negative 81i. So watch this. Negative 81i, so negative 81 second decimal to get the I, times 9 second decimal to get the I, equals 729. And y'all look at that. Negative 729 plus 729 gives us 0. But we knew that because they told us 9i was a 0. So now what you got to do is take these 4 coefficients, 1, 9i, negative 9, and negative 81i, and do synthetic division. Now, we automatically need to check the negative 9i next. Because y'all, we cannot use the quad until we get down to 3 numbers. Now, after we do this synthetic division, these 3 numbers that are left, That'll give me my A, B, and C. I can use the quad to find the final two zeros, okay? But we had to know this was a negative 9i because of the conjugate pairs to get to this second zero, okay? So the 1 come down. 1 times negative 9i is a negative 9i. Well, when you add 9i and negative 9i, you get 0. 0 times negative 9i is a negative 9i. Whoops, my bad. Y'all, 0 times a negative 9i is a 0. Woo, I'm getting bad. All right, so remember, 0 times negative 9i was 0. Negative 9 plus 0 gave me negative 9. And y'all watch this. Negative 9 times negative 9i is a 81i. So that when I add a negative 81, positive 81i, I get a 0. So we knew negative 9i was a 0. Now we got to get the last two zeros. So since there's three numbers, so since three numbers, we can use the quad formula. Or you can solve it using square roots. Or take square roots. Okay? So remember, this would be the x squared term, the x term, and then your number. So you would have an x squared plus 0x minus 9 equal to 0. To solve that, add 9 to both sides. I get x squared equals 9. Then I would take square roots of both sides. But remember, when you take the square root of a number, you need a plus and minus in front of it. And y'all, that's how they're getting that plus and minus. These radicals come in conjugate pairs because of these two signs right here. So this gives me a x equals a plus or minus. Square root of 9 is 3. So the remaining zeros were negative 9i, 3, and negative 3. Now, that's why I was trying to get y'all to download that program I had in the calculator, because once you got it to three numbers, you could have went down here and hit my quad program that I sent y'all and put in the 1, 0, negative 9, and it would have spit out 3 and negative 3 quick. So at this point, we want you to use the synthetic division, get it to three numbers, and then hit it with that quad, okay? All right, y'all, so moving on. So here's some more info. To find all possible rational zeros of a polynomial, so they're talking about numbers you might check for zeros, because if you don't know the right numbers to check on synthetic division, you could be there a while doing synthetic division checking numbers, okay, just to find one zero. So we got little things we can do to eliminate needless guessing, okay? So to find all possible rational zeros of a polynomial, we take all factors of the last number and divide by all factors of the first number. All factors of the last number divided by all factors of the first number. So this example, we're going to find all possible rational zeros for the function p of x equals, let's see, 10x to the third minus 34x squared plus 46x minus 21. So the first thing I know, last number, is 21. And I don't even care about this sign because we're going to take that sign when we do these, okay? And the first number is a 10. So let's find the factors of 21. That'll be 1, 3, 7, and 21. Those are all the factors of 21. And then all the factors of 10 would be 1, 2, 5, and 10. So what I'm going to do is start with the 1 and divide by all these numbers. Then I'll take the 3, divide by all these numbers. Then I'll take the 7, divide by all these numbers. And then the 21, divide by all these numbers. Now, every one of these will be plus or minus. So I'm going to start with my 1. So take the 1, divide by the 1. That's going to equal plus or minus 1. Then I'll take that 1, divide by 2. So a plus or minus 1 divided by 2. Can't do nothing else to that. Then I'll take the 1, divide by 5. Plus or minus 1 divided by 5. And then finally, plus or minus 1 divided by 10. So divide 1 by all factors of first number. So that would give me 4 numbers that I could check. Really 8 because it could be a plus 1 or a negative 1. Now, I'm going to take the second number 3 and divide by all those numbers. Now 3 over 1 will simplify to a 3. Then I'll take 3 divided by 2. Take the 3, divide by 5. And finally, take the 3, divide by the 10. So this one I divided 3 by all factors of first number. Hey, what's next? I got a 7. That was a factor of the last number. So I'm going to take that 7 and divide by all of those. So 7 over 1 will simplify. Then I get a 7 over 2, 7 over 5, and then a 7 over 10. Well, let's divide 7 by all factors of the first number. I'm running out of space. And then finally, I got to take the 21 and divide by all the factors. So plus or minus 21 over 1 is just a 21. Plus or minus 21 over 2. Plus or minus 21 over 5. Plus or minus 21 over 10. So divide 21 by all factors. So that's all these, the 1, plus minus 1, plus minus 1/2, 1/5, 1/10, all these numbers are possible zeros. I'm not guaranteed they're zeros, but these are the numbers I would check to find zeros for this polynomial, okay? If it's not a factor of 21, it's definitely not going to be a zero of that, okay? All right, so this last one will show you where they came up with that at, okay? So it's going to be a doozy. But these ones will be like your 16 and 17 and so on in that homework. So let's end it on a good one, right? So find all rational zeros and then the other zeros of the polynomial that are giving me, let's see what this is, f of x equals 2x to the third plus 7x squared plus 98x plus 343. Now, after I do that, then we're going to factor into linear factors. So basically, they just want me to put them back in parentheses as factors instead of zeros, okay? So here's my polynomial. So let's write down the coefficients because we know we're going to be doing some synthetic division. So I got a 2, a 7, a 98, and a 343. Now, 343 has a lot of factors, okay? So I know 1 goes into 343. Let me see if that thing will divide by 3. No. I think next would be a 7. So 7s go into it, which means 49 went into it, and then 343. So I think it's just a bunch of 7s that make this up. So all these could be plus or minus. Remember, if none of these factors work, then I would divide all them by a 2 and try those numbers, because we're not guaranteed to get any whole numbers. It could be fractions. So let me show you what I do to eliminate the guess. I go to y equals, and I punch this in. 2x to the third, arrow down, plus 7x squared, plus 98x, plus 343. I'm going to graph it because I know zeros are where it crosses the x-axis. So if I can graph that and see places where it's going across the x-axis, I can use that as my 0. And I see right here, it looks like it's going across. But y'all look at that. That looks like it's in between my numbers, doesn't it? And to verify that, I can go to graph. And that was about at a -7. And notice I'm not getting a 0 anywhere, which means all the whole numbers ain't going to work. It's definitely going to be one of these fractions. So watch this. Let me go back to that graph. This is what? 1, 2, 3. That looks almost between 3 and 4. So which one of these numbers, when you divide, will give you a number between 3 and 4? So watch this. 1 divided by 2. No, that gives me 0.5. 7 divided by 2. Oh, that gave me 3.5, which means -7/2 will be the first one I go because that's on the negative side and it's in between 3 and 4. If that didn't work, I'd have divided 49 by 2 and then 343 by the 2. Because I know it either had to be one of these divided by 1 or one of those divided by 2 because that's the only factors of 2. So I'm going to try -7/2. If I'm right, I'm going to get a 0 here, and then I'll use the quad to get my last 2 zeros. Because I know altogether will be 3 zeros. So That makes sense. I'm sort of using factors to get my guesses on this because this problem, they're not giving you a 0 to start with. All right, y'all, watch this. 2 comes down. 2 times a negative 7 halves. 2 times negative 7 divided by 2. You're going to notice the 2's will cancel, and that should give me what? A negative 7. All right, 7 plus a negative 7 is 0. 0 times negative 7 halves is 0. 98 plus 0 is 98. And y'all watch this. 98 times negative 7 halves, which is negative 7 divided by 2. It better give me a negative 343. When I add, gives me a 0. So we were right. We got the first 0, which was negative 7 halves. Now, to get the last 2 zeros, remember, I got 3 numbers, so I can use quad or square roots. Okay, so remember, this always starts 1 degree less, so this would be 2x squared plus 0x plus 98 equals 0. All right, y'all. I'm going to solve this by square roots because that's pretty quick when you don't have that x. Anytime you got a 0 in the middle, I would probably do the square root method. Just watch this. I subtract 98. I get 2x squared equals negative 98. Next, before I do square roots, I would divide that by 2 so that I get x squared equals a negative 49. All right, y'all, to get these last 2 zeros, we're going to come in and take a square root of both sides. So this side will be a plus or minus square root of 49. All right, square root of x squared is an x. That's going to equal plus or minus square root. Whoops, I had a negative 49 under there. Square root of a negative 49. So second square root, negative 49. If you get a non-real answer, watch this to fix that. Go to mode. Go down here where it says real and go to the right and hit enter. If you keep it in this mode now, when I do the square roots of the negative numbers, watch what it does. Second square root, negative 49. Instead of giving me an error message, it gives me what the square root of a negative 49 is, which is a 7i. So my zeros that were left that I found were negative 7 halves, 7i, and a negative 7i. So it would ask me, the negative 7 halves, that's my rational 0. The 7i and the negative 7i are imaginary zeros. So you would put negative 7 halves in the spot where it said rational zeros, and then the other zeros are, you would put the 7i in the negative 7i. So linear factors is they want me to put all those in parentheses. So you'll have a x minus 7i. Whoops. Now, y'all, watch what you got to do on this. This would be plus 7 halves. This one, since it's positive, would be minus 7i. And this one, since it's negative, would be a positive 7i. Now, the reason I wanted to do this one, since this has a 2 on the bottom of a fraction, you got to put a 2 in the front of that. Because that way, if you foiled it, it would cancel this fraction out and make it a linear problem. So for some reason, they like you doing that on that one. Oh, let's see. Yeah. All right, so this right here would be the linear factors. put an X in front of them, change their signs, and put them in parentheses. If you got a fraction, you got to throw the denominator in the front. Other than that, you wouldn't do nothing to them and just move on. So y'all, that's pretty much 8.4. So I'll be sending this video out in a little bit. And I didn't want to keep y'all too long on a Friday. So I know how y'all been sort of busy. Main thing, test 2 is due by Sunday night. Test 2 bonus is due by Sunday night. If I got your bonus already, I already added it to your test. So I'm going to stop our recording.